Welcome to this presentation about unlocking valuable sports insight, analyzing sports code XML files with DuckDB and Kloppy. This was actually a presentation during the PySport Meetup in Eindhoven, but something went wrong with recording, so I'm actually re-recording it right now. So questions from the audience are missing, but yeah, I think it will be fine. So, short content of this presentation. I will begin with an introduction, why this presentation is there anyway, then some words about DuckDB, then go into Kloppy, then have a lot of code, and then jump into some conclusions. So the introduction, why this presentation? I think it's interesting to see that a lot of video analysis people create a lot of data, the XML files. A lot of manual tagging is done, and I think that's really valuable. But in the end, the data is mostly only used for purpose of video analysis. And I believe that if you use the right tools, that you could also get more insights, for example, trends over multiple matches, and more insights from that data. And in this presentation, I give you a short introduction on what tools you can use and how to glue those tools together to get some insights. It will be short of a sort of basic introduction, and you can play around later on, as all this code will be available later on. Then DuckDB. DuckDB is an in-process SQL OLAP database management system. This description is not mine. It comes from the DuckDB website. What this actually means, the in-process part is important, SQL is important, and the rest for this presentation is not that important. But they also have a short description why DuckDB. So it's simple in process. Keep that in mind. It's important. It has APIs for Python, R, Java, a lot of APIs. Also, you can run it in the browser. That's pretty interesting. It's fast, so it's a vectorized engine, which means it can do pretty quick calculations based on a single column. Optimized for analytics. That's great because we are doing analytics. Parallel query processing. Well, I think for the amount of data that we're using right now, it's not that important, but when you're using a lot of data, it's really convenient. Feature rich transactions, we won't use it, but extensive SQL support is pretty cool. And also the direct Parquet and CSV querying. We will not use it, but it's pretty useful. And then in the end, it's free. Permissive MIT license, that's also really nice, so you can use it in all your projects, without messing with licenses. But then let's have a look in the in-process database versus external database. For this presentation, that's pretty important. And what's the difference? So let's have a look. The in-process database means that you have your application, and part of your application is the database engine itself. And that's the entire application together with your database engine will run, for example, on your laptop. And when you have a look at the external database, in your application, you'll have a database connector, which is part of your application that runs on your laptop, and over the network you will make a connection to a database server that actually runs the database engine. So there are some advantages and disadvantages of both cases. For the external database, now of course you need a separate database server. You can also run it on your laptop, but at least you need multiple processes running. For the database server, the external one, also multiple people can work on the same data at the same time. But in process a database, you don't have to start a database server. You don't need any special things. You can just run your application and it works. But then there's also a difference in the in-process databases, because SQLite is also in-process database, and so is DuckDB. But there's a slight difference there, which is quite important for this presentation, because the difference here is that SQLite requires you to first put all the data into the database and then run queries on the data. And with DuckDB, you can run the queries directly on your source data. And in the why DuckDB slide, it already said that it can query Parquet files, CSV files, but it can also query data frames. So a pandas data frame can be used directly without first inserting the data into a database. In this case, I also added Excel. There are a lot of plugins for DuckDB, and I expect there will also be one to query Excel files directly from DuckDB. Then let's have a look at Kloppy. Kloppy started as a tool to standardizing soccer tracking and event data. A lot of vendors use different formats for their data, and you don't want to have the vendor-specific code spread it all over your code. So that's why where Kloppy started. So it's a library which you can use to read all kind of data, tracking data and event data. It will be standardized, and in your own code you don't have to think about the actual source or the vendor. So what can I do? And also load some public data sets. Some companies like Metrica, StatsBomb, Wisecout, Skill Corner, they provide open public data sets which can be used to play around and do some research on. Kloppy allows you to read that data without any knowledge of where it's hosted. It will also do some caching of the data, so that's pretty nice to get going. It also provides standardized data models for the tracking and event data. So it provides models for the data itself, but also for players, for the match, for metadata. And out of the box, deserializing the tracking and event data, it will just work for you. Then the processing of the data, it can go from different picture dimensions. So for example, one vendor can use dimensions in actual meters, the other one can do it between 0 and 100, and Kloppy can make sure that it's aligned, so you can match your Opta data to your TrackApp data. But can also change orientation. For example, event data is mostly oriented from the ball owning team or the action executing team, and TrackApp data, so the tracking data is fixed, and if you want to use it together, you might want to make sure it's in the right, in the same orientation. But let's have a look with some nice pictures I drew a while ago. So what actually happens, multiple vendors can watch the same match and have their own definitions for the events and also for the coordinates of those actions. So it will be the same match describing data describing the same match, same events, but with different definitions, and Kloppy tries to help it and fix it. So you can put in an XML file or JSON depending on the vendor. It will unpack it and standardize it, and in the end, well, it's shiny and blinky. It's great. Yeah. So how does it work? I was talking about event data, tracking data, but Kloppy also supports XML data. in SportsCode format. Most tools like Naksport, Team TV, Game Breaker, My Video Analysis tool to all support the SportsCode format, so you can read it, so it can be tagged manually or retrieved from data provider. We will extract it, transform it, and then you get a standardized data set, which is all Python objects, which can be used to analyze the data. Or you could also transform it to a data frame in pandas or polars format, and then you can analyze the data. Now let's have a look at some code. I got some data from FieldHockey, and I think most of the processes work for any kind of sport. Of course, you need to know a bit about the sport itself to make it actually variable, but the code can be pretty much the same. So that's why I used data from FieldHockey from Oranje-Rood, Netherlands. But it's quite easy to do the same for your own data. So let's first install Kloppy. And I think in this environment, yes, I already installed it, so I don't have to worry about it. Then next step would be to import the SportsCode deserializer, which is part of the Kloppy package. The next step is to actually load the data. So there are only two steps to load the data: import SportsCode and then load the data set. And then I have the data in this variable. And let's have a quick look. Yeah, so this is the data. So each record contains the code. It gets some kind of period ID and the timestamp of the data. And this will show I have to do some more work because the period is all 1. The time is the time for the entire match. So I have to fix it later on. But these are plain Python objects, no pandas or polars whatsoever. You can do some basic analysis already. So let's do some pre-processing. So you might have seen that the data contains code with the start. That means the start of a new period. So I do some minor pre-processing here. So if we start without a period, when there is already a period, we end it, and we create a new one. And all the records we assign a new period, and we make the timestamp relative to the period timestamp. I also need to run it, of course. And then if we look at the same data, we will see that the period ID and the timestamps, they will change. So there's a start, which has a period of 2 and a timestamp of 0. That's nice, because now, is it correct? Yes, so we also have correct periods. So in FieldHockey you have 4 periods, 2 halves. And we can do like a drill down now on the period as well. Now let's do some data cleaning, because there are a lot of data in it and we only want to look at player data. So we have some players, we just have a list here, so Gijs, Jamie, Sander, Jelle, Sheldon and Phil. And we will filter a data set based on those players. In this case the code contains the name of the player. So we can, in Kloppy, we can just filter it. It will be a new data set. It will not change the original one, but you get a new data set which contains only the codes of the players. Let's have a look at it, and now we'll see here on the left side that it only contains the players. Okay, we can convert it to a pandas data frame. That can be useful for any kind of analysis, and also for usage with together with DuckDB. We need to have it in a pandas data frame, and I think it also supports polars, but in this case I will use pandas. Kloppy supports export to to pandas, to polars, and since the latest version 3.10 also the pandas arrow format. So if you run it, we will see it contains a code, period, timestamp, and timestamp, code, URL, passing, quite some information. This is all part of the XML file. So now we can already play around with it. So let's use DuckDB for it. I hope it's already installed. Yeah, so for some statements, like the pivot statement, we need the preview release, which is 0.7.2. This can be installed using pip. It's just a development release, preview release. And let's see. So when we run a in-memory database, you don't have to pass anything. And now we have a connection with our database, which runs in our own application. And we can run a query. Some things that need to be said about this query. So we select some columns. In this case, the timestamp, the code, which is the player. If we won the duel, lost it, and we only want to have the data where this column is set or this one is set, ordered by the period ID, the timestamp, and limit to 10 rows. But where does the data come from? We read from players data, but we never told DuckDB that we have a table which is called players data, and it's also not part of the database. So that's what's pretty interesting about DuckDB. When there is a data frame with a certain name, which is assigned to a variable, in this case, in this one, it's called players data, we can use it to query. So we're querying our data frame directly. So that's also the difference between SQLite and DuckDB. So with DuckDB we were able to run this query without storing the data within the database, and just point it to a pandas data frame. And we can run some other queries on it, do a group by. DuckDB also supports the group by all, which means it groups by all the columns which are not an aggregate. And here we already see that for each player we can see per period the number of duels that they won or lost. This already gives some insight. So we can see that Gijs mostly won in the first period and lost in the last period. But those column names, they're not really handy to work with. So let's change them a bit. So what does encoding looks a bit like one hot encoding, which means there's a column for each possible value. So if we won the duel, there's a column, and if we lost the duel, there's a column. But in this case, I would prefer to have it in a single column with just a value won or lost. So this is all the steps that we do. So we do a filtering on the players, and also do a mapping. If it contains a column which is named duel plus, then we will have a value of 1, and otherwise if there's a column with a true value in it called duel minus, we use the value lost. And when we go to a data frame, we can specify which columns that we want. In this case, the period, the player name, and if the duel is won or lost, and we can specify a function for it. So we can use a lambda function or use a one which is specified here. Okay, and how will the data look like? Well, that's awesome. So we have a period ID, the player, and duel contains values of won, lost, and also none. We might filter it out, but right now we just keep it in. But now we can query the data again. So we can count the number of rows and add some filters, so we only want where the column duel contains the value 1. We also want to make sure it's either won or lost. We can also change it to, let's do it in won, lost. So. And group by again and sort on the player name. We can also change it to the percentage of duels that are won. It's quite an ugly one. It can probably become a bit easier. I think also this conversion to a decimal won't be needed in some of the upcoming versions. But in this case, we can have all the values as a percentage. So this again gives us some insights. We will see that Gijs again won in the first period and lost everything in the last period. One thing that's missing is the absolute number of duels. That might be more interesting, as we cannot see if Gijs, well, if he didn't have any duels, he won't be listed here. So at least he lost everything. Okay, but the next step is, and that's a new statement from DuckDB, and that's also why we needed the latest version, the 0.7.2. It allows us to do a pivot. It's similar to a pivot in Excel. And let's have a look at it. Okay, so we can pivot players on period ID using the first value of the duel, percentage, and group by player. So we get the periods as columns and the players as rows. So now we have a nice overview of all the percent per players. If there was no data, we will see the null. But now we only have the data for a single match, and I think what's really interesting is to see how we read the data from multiple matches to get, for example, a trend. And that's also possible. So let's have a look at the code again. We've seen this before, but let's do it step by step. So first the code to clean it a bit. Then, there's a load file over here. It's also the same we've seen before. Fix the periods. And the only thing that we do, can I scroll? Oh, there's a match. So we also put a match column into the data, so we can group by and do some other stuff on top of it. Let's run it. Okay. So in this case, the XML files are in the files directory, and the player data contains space 2 in the file name. Well, that's how we work, right? We can read all the files. So there's a 1 against this team, against Den Bosch, and I think it's Klein Switzerland. So we have 3 matches in our data set, and let's see how this works. In this case, we will create a combined pandas data frame, load all the data, and the load will already return a pandas data frame, and we concatenate it to a single one. And now we will see that we also have a match column which contains the match, it's the name of the match. That works fine. And then again, we can do the same based on the match. And that's something interesting going on here. For this match, there's only 1 period, so probably the data preparation is a bit off for this match. So if you would use this in an actual situation, you have to dig into the data and see how we can fix it. But as you can see, we can already run a query on all the data. Now we run this query, and these are the results. Yeah, if you want to get started and you don't have your own XML files, you can also use the open football data, which works almost the same. In this case, I will use the StatsBomb open data, so I filter it based on the passes. Then go to a data frame, which I only want the team, the player, and a result. So we get, based on a player level, all passes with the result. How does this look like? In this case, it's a match between Barcelona and Deportivo. We see the result: complete, incomplete. There are some more types, we'll see it later on. But there are quite some passes in the match, and we have the 3 rows. So let's, this one is, I changed it, wait. Okay. So you could also read it from a Parquet file. But now we want to read it from the pandas data frame. So let's do it. Group by all, yes. So now we get per player, we get the number of complete, incomplete, and out passes. Also offside. Okay, that's interesting. So now we can already explore the data, just reading it in a single step, and then run a query on top of it. We can also do the pivot again, so you can see that Barcelona, the pivot on the result. So we get columns, they complete, incomplete, offside, and out. And I think this also gives an overview of the match. So similar amount of incomplete passes, but complete passes totally different. So just in a couple of lines of code, you can get those insights. Let's do it based on shots. It doesn't really fit nicely. But in this case, we filter all the shots per team, per player, per result, and also do the pivot. And now you can see per player if they have a blocked shot, goal, off target, post, or saved. In this case, you can see that Messi scored 2 goals. You can also could do some more filtering, that we only want to have the goals or players that scored a goal. But in this case, you can go directly from the shot data to this table. Yeah, export to Excel is also possible. We need a different library for it. Oh yeah, it's already installed. And the results from the query, so that's this result. So this table, we can go to a pandas data frame again and go export to Excel. Well, now it's exported. I'm not really sure if I also will be recording. Probably not. No, I'm not recording my entire screen. But you have to trust me. When I run this cell, I will get Excel open with the table inside Excel. So you can also go pretty easy from the raw data to a query to an Excel as an output, and that makes it possible to automate your workflow. Then some conclusions. Yes, Kloppy can be used to read the SportsCode XML files. Data cleaning, transformation can be done in just a few lines of code. The cleaned data set can easily be transformed into a pandas data frame, and DuckDB can be used to directly query those data frames. There's also a question slide, but that's a bit difficult with this recording. But thanks for watching, and you can also reach out to me on Twitter or LinkedIn or whatever medium you like. Thanks for watching.